So in the past, we've talked about velocity and displacement. So now we're going to be talking about acceleration. So acceleration is the rate of change of velocity. So how fast does the velocity change? And that's why it's given by the formula change in velocity over the change in time. So V1, V minus V naught, which is the initial velocity over time. So change in velocity over change in time gives us the acceleration. In other words, it's the slope of the velocity graph and at the rate at which velocity is changing. And just like velocity, acceleration is a vector quantity, meaning it has a direction and it can be either positive or negative depending on the direction. If it's going on the right, it's generally considered positive, left is negative, and the most common type of acceleration is gravity, which is negative acceleration since it's downward, has acceleration of negative 9.8 meters per second squared. And yeah, the units for acceleration are meters per second squared, and velocity is meters per second. Okay, let's do some examples. So a cat chases a mouse till it gets tired. We're given the velocity and the time. So what is the average acceleration from 12 to 24? So to find this, we have to find the slope of the line. So we're given 2 points. So we're given a point 12, comma 8, and the other point is 24, comma 0. So we just have to figure out the slope of the line given these 2 points. So we can just do y2 minus y1 over x2 minus x1. The x is 24 over 24 minus 12, which is equal to negative 8 over 12, which is negative 2/3 meters per second squared. So that is the average acceleration from 12 to 24 seconds. So another similar question, a dog chases a cat until it gets tired. What is the average acceleration from 0 to 12 seconds? So we write down the points again. We have 0, comma 0, which is this point. And then we have this point right over here, which is 12, comma 8. So y2 minus y1 over x2 minus x1. So 8 over 12. That simplifies to 2/3 meters per second squared. And if you notice, the similarity between these two questions is that one is negative and one is positive, which makes sense because they they actually have pretty much the same slope, except they're in the opposite direction. This is positive and this is negative. Another question. So you can try this first and then I'll explain it. Okay. An ostrich accelerates from rest until it reaches a speed of 6 meters per second. And it's shown below. So it starts over here, its velocity is 0, then it goes up, goes up, goes up, and then until 9 seconds, it increases velocity, and then it takes a break. The velocity is constant. So what is the average acceleration from 9 seconds to 18 seconds? So we have to find the slope, but we know if that line is flat, that means the ostrich is taking a break. So it actually does not have any acceleration. So the acceleration is 0. And if it doesn't make that much sense, we can also just take numbers. So 9, comma 6, and then we have 18, comma 6. y2 minus y1 over x2 minus x1. So 0 over 9 is 0. Another practice problem. David drives and slows to a stop when he sees a stop sign. So he's driving and he slows down because he sees a stop sign over here. So we're given the velocity time graph and we're asked to find the average acceleration. So once again, we have to figure out the slope of this line from 10 to 20 seconds. So figure out our 2 points since it's linear. 10 comma 20, and then it goes to 20 comma 0. So y2 minus y1 over x2 minus x1. So that is negative 20 over 10, which is negative 2 meters per second squared. So when the sign is negative, that means it is decelerating. Negative acceleration means decelerating, just going in the opposite direction, or in this case, it's slowing down. If it would continue, that means it would be going in the opposite direction.